Welcome students. In today's lecture, we will discuss derivative of complex function. So to understand derivative of complex function, first we need to understand what is complex function. And then we will understand derivative, and then we will solve some examples to understand how to get derivatives in case of complex. Complex function. So here C is taken as the set of complex number. So any function defined on C is a rule. It is a simple rule which assign every z in xy plane, every z in xy plane to a complex number w in uv plane, every z in xy plane to a w to uv plane. From here, what is most important is that you need to understand w is the function of fz and w is in the form of u plus iv. At z, what? Z is the function, z is the form of x plus iy. The real part of z is x and the imaginary part of z is y. So, but in case of w, the real part will be u, which is the function of x and y, and v, imaginary part, which will be the function of x, y, and y again. So u plus iv, that we have to remember. W equal to u plus iv, and u and v are two real functions. Now to understand this, let w equal to fz equal to z square plus 3z, then find u and v. First we will solve this. So it's very simple question. Put z equal to x plus iy whole square plus 3 x plus iy, a plus b whole square. I applied here. So x square minus y square. Minus y square is because of this iota. Iota square is minus 1. So 2ixy plus 3x plus 3 iota y. Now to get u plus iv, I need to separate real part and imaginary part. Real part is the part which is free from iota, and imaginary part is the part which is the multiple of iota. Iota times of 2xy plus 3y. So this is my u, and this thing without iota is my v. In next part it is asked that calculate the value of function f at 1 plus iota. So to get this, put 1 in place of x and 1 in place of y. So 1 square minus 1 square plus 3 plus iota time 2 plus 3. So this will give us 3 plus 5 times iota. So this is how we solve such type of question. In next question, w equal to fz 3iz plus z bar, find u and v and calculate the value of the function at 2 minus 3 iota. You try it your own. Now we will understand what is derivative. Derivative of complex function w equal to fz is given by this formula, dw by dz at z naught. This is written as at z naught. It is also given in the form of f dash z naught equal to limit delta z tends to 0 f of z naught plus delta z minus f of z naught divided by delta z. It is very similar to the definition of differentiation by first principle. Okay. Similarly, f dash z naught can be given as limit z tends to z naught, because here I am taking z minus z naught as delta z. If I will substitute z minus delta z naught equal to this, so in place of z plus in place of z plus delta z, I will get z, and in place of f of z naught I will get f of z naught is okay. In place of delta z I will get z minus z naught. So this, and limit, since delta z is 0, so this will give us delta z is 0, so z tends to z naught. So we are going to use this definition for our future. Now in next part we will solve some question of derivative. To solve those questions, one thing is you need to understand that this limit has to be same from all the paths. If limit is different from any single path, then we will say limit does not exist. If this limit does not exist, then we will say derivative does not exist at that particular time. Again, very important thing, so I am repeating it one more time. To understand this, this limit from z tends to z naught has to be same from all the path. All the path means, suppose this is my z naught and this is z is anywhere in the neighborhood of z naught. So if z approaching like this, z approaching like this, z approaching like this, and then we will calculate the limit from all the infinite number of paths, because there will be infinite number of paths, all the paths should be same. But it is very difficult to get the infinite number of paths, so but we can use this thing to disprove. Disprove means, if we can say that if limit does not exist, we can prove it very easily. How? If suppose I took the path 1 like this, so this is suppose path 1 and this is path 2, and limit from path 1 is coming like a or 1, and limit from path 2 is coming like 2. So then we can say limit from two paths are different, so limit does not exist. If this limit does not exist, then derivative does not exist. Okay, so we will use this concept in our future. Now we'll use that concept in this question. Fz equal to z bar, then check whether the following functions are differentiable at z equal to 0 or not. So at z equal to 0, the point is given us, that is z equal to 0. So f dash z naught equal to limit z minus z tends to z naught fz minus this f dash 0. Put what is the here, z naught equal to 0 given us, so 0 fz minus f0 divided by z. So I am solving the first question, a part. So x minus iy, z bar means x minus iy divided by x plus iy is this z. Now this function, we can use one approach which we have learned earlier. In general way, we use like this is our z and we go like this, path 1 means first we drop to, this is y-axis, this is x-axis. What we are doing here, we are dropping that y at 0. So what path 1 means, let me path first. Path 1 means what we are doing here, we are dropping y at 0 and then we are tending x towards 0. So this is path 1. So take like this, suppose path 1. So then limit will be x tending to 0, y is already 0, so x divided by x, so this is equal to 1. Now choose part 2, some another path. In general we take this path. This is not a rule, but not a mandatory rule, but in general we took like this, we take like this, sorry. So z goes, first we draw what here for path 2, red one, what we did here, x equal to 0 and limit y tending to 0. So let's see how it works. So limit y tending to 0. Now here you can see that x is already 0, so iota y divided by iota y with negative sign, so it's coming like -1. So limit from two different path is not same, so we will say limit does not exist, hence the function is not differentiable at z equal to 0. This is how it. One more approach is there, because sometimes it is quite difficult to take different paths and making that. In that case we can use another approach. That approach is, now look, now you will have to observe the function. If you observe the function, this function is homogeneous. Here x minus iy, here x plus iy, means the power in denominator and the power in numerator are same in both cases, x and y, for both. So in that case, if the function, if the power is same, then we go like this, take, this is another approach, that was the first approach, I am taking the second approach, second method. Take path like y equal to mx, take y equal to mx. Okay, so after taking y equal to mx, I took the path, so all the y will be converted into x, so limit x tending to 0, x minus I mx divided by x plus I mx. So this is equal to, I will x will be cancelled out from here and here, so I will get here x minus iota m divided by x plus iota m. Now for different value of m, I will get different limit. For different value of m, I will get different limit. It means limit depends on m. So we will say, since limit depends on m, so not differentiable. Not differentiable at z equal to 0. This is another approach. Now we'll try second question. Fz equal to xy square plus into x plus iy divided by this. This, what is the difference between this and this? Here the function is defined in the interval. For z does not equal to 0, different values given. For z equal to 0, different values given. So how to deal with such question? Again, same definition. F dash 0 equal to limit z tends to z naught. Z naught is 0 here. Fz minus f0 divided by z minus 0 equal to limit z tends to 0. This function fz is this minus f of 0 is 0, minus 0 divided by z is x plus iy. X plus iy and x plus iy will be cancelled out. So I will get limit z tends to 0, xy square divided by x square plus y power 4. Now here if we check, then this is not homogeneous. Here the power is 3 x y square, but here power is 6. X and y, the power are different. The power of x and the power of y are different. So in that case, what we do, here you can see that the power of y is double of the power of x. So to make it homogeneous, we can take this x equal to my square as our path. I am taking x equal to my square, so take x equal to my square as my path. So what will happen? All the x will be converted into y. So limit y tending to 0, because all the x will be converted into y, my power 4 divided by m square y power 4 plus y power 4. This is equal to, take y common from here and it will be cancelled out. So the limit is coming m divided by m square plus 1. So again, limit dependent on m, so not differentiable. So not differentiable at z equal to 0. So the function is not differentiable at z equal to 0. I hope this is clear now. We can try one more question. This function is also not differentiable. Let's see, is it true or not? F dash 0 equal to limit z tends to 0. The same definition. Put fz is this much, okay, divided by z is this. So now here you can see that the power of x is homogeneous. This is homogeneous. X square here, and the power is again here 1 power. So this will become 2 power. So same. So this is, so it can be treated by taking which path? Y equal to, yes, mx. Sorry. So it can be solved by taking path as y equal to mx. Let's see. So once I have taken this path y equal to mx, so all y will be converted into x square 2 plus iota plus, sorry, erasure, minus m square x square into 1 minus 2 iota divided by x plus my, sorry, x plus mx into x plus iota time of mx. Okay, you can take x square common from here and x as well as x common from here and x common from here. Again, you can see that the overall it will be here. You will get a function of m here. So the limit depends on m. So again, this function is not differentiable at z equal to 0. You can try it, very simple. X square, this you can take common from here, x square, this is x, okay, so x square take common from here, you will get here 2 plus iota minus m square, 1 minus 2 iota divided by 1 plus m into 1 plus im. So this is dependent on m. For different value of m, we will get different limit. So limit does not exist. Since limit does not exist, if this limit does not exist, then f dash 0 does not exist. So it is not differentiable at z equal to 0. So this is all for today's lecture. In next lecture, we will discuss about analytic functions, which is a very important concept here. Thank you.